All right, we are about to jump into one of the biggest, most mind-bending questions you can imagine. It sounds so simple on the surface, but it goes right to the very heart of reality itself, and it has fueled a debate that has been raging for centuries.
So here's the big question. Is mathematics some kind of universal truth that we just uncover? Kind of like an astronomer discovering a new planet? Or is it a powerful tool, maybe a language that we invent to describe the world, like we invented music or chess? Are numbers real things, or are they just really useful ideas?
And look, this isn't just some abstract puzzle for philosophers sitting in an ivory tower. Your answer to this question actually shapes your entire worldview. It decides whether you see the universe as having this pre-written logical structure that we're just reading, or if you see it as a chaotic place that we, as humans, are imposing order on. The stakes really couldn't be any higher.
Okay, so to really get to the bottom of this, we need to understand the two major armies in this intellectual battle. These are two fundamentally different ways of seeing the world. This is the core philosophical conflict right here.
So on one side, you've got the Platonists. They believe that things like numbers and shapes are real objects that exist in some abstract, perfect realm, just waiting for us to find them. And then on the other side, you have the Nominalists. For them, math is a human creation. Abstract concepts like infinity, they aren't real things. They're just useful symbols, a convenient way of speaking or façon de parler that helps us organize our thoughts.
But wait, there's actually a fascinating third option, Intuitionism. And this view basically argues that both of those other sides are kind of missing the point. For an intuitionist, math isn't discovered in some abstract world, and it's not just a symbolic game either. Mathematical truth is actively created through the constructive processes of the human mind. It's really the study of our own mental functions.
All right, so let's just quickly recap the three camps here. Platonists believe math is real, and so it's discovered. Nominalists see it as a system of names, which means it's invented. And intuitionists argue it's a mental construct, which means it's created. Three completely different foundations for the exact same subject. Wild, right?
So, how do we even get to these complex ideas in the first place? Whether you think math is discovered or invented, we all use the same fundamental cognitive tool to make sense of the universe, and that tool is called abstraction.
You know, just think about the world around you for a second. It's this overwhelming flood of sensory data, what the source material here calls the entropy of experience. Abstraction is the tool we use to tame that chaos. It lets us filter out all the noise and create clear, precise, manageable ideas that we can actually work with. And this amazing tool, it really comes in a few key flavors. First, there's idealization, which is where we simplify things down to their core principles. And then there's identification. And this is a crucial step where we decide that two different things can be treated as the same. Let's break those down.
Okay, first up is idealization. This is something that, honestly, we all do. I mean, no surface in the real world is perfectly frictionless, but physicists imagine one all the time to make their calculations clean and precise. We intentionally simplify reality, stripping away all the messy details to get at an underlying principle. It's kind of like a necessary fiction that actually leads us to powerful truths.
Okay, this next one. This is arguably the most important of all. It is the very engine of logic and reason itself. The creation of sameness. I mean, really think about it. No two apples are ever exactly the same, right? They have different atoms, different little blemishes, but we perform what's called an abstraction of identification. We actively decide to treat them as the same for the purpose of, say, counting them. We create the category apple. Sameness isn't something we just find out in the world, it's a concept we impose on it. And this whole act of creating sameness, it isn't just random, you know? It's governed by these ancient, really powerful rules. The most basic one is reflexivity. An apple is an apple. Simple enough. Then there's symmetry. If we say this apple is equivalent to that one for counting, then that one is also equivalent to this one. And finally, transitivity. If apple A is like apple B and apple B is like apple C, well then A is like C. These simple rules build the entire structure of logic.
But, and this is where it gets really interesting, this simple idea of sameness or equality drops us right into a massive philosophical rabbit hole. That innocent little equal sign is hiding a huge identity crisis.
So the most basic law of logic, you'd think, is A equals A, right? A thing is itself. You really can't get more obvious than that. It's a statement that is always, always true, but it also tells you absolutely nothing new.
And that's the puzzle. If the only true identity is A equals A, then how can a statement like, the morning star is the evening star, be useful? We actually learn something new from that statement. It's informative. But if the morning star and the evening star are truly identical, then saying they're equal should be as useless as saying A equals A. So, what gives?
Well, the breakthrough really came from this brilliant philosopher, Gottlob Frege. He realized everyone was looking in the wrong place. The problem wasn't about the identity of the objects themselves. No, it was about the identity of the signs, the names or the symbols we use to point to those objects.
So here's the big idea. The morning star and the evening star are two different signs, two totally different descriptions that just so happen to point to the exact same object, in this case, the planet Venus. So a statement like A equals B becomes informative because it tells us that these two different paths of meaning actually lead to the very same destination. It connects our knowledge in a powerful way.
And, modern philosophy takes this even a step further to deal with the messiness of the real world. When we measure something, we're never perfectly precise. So instead of thinking of identity as a perfect single point, we can think of it as an interval, a tolerated range of similarity. Two measurements are identical if they fall within an acceptable margin of error.
Okay, I know we've been deep in the weeds of philosophy and logic, but why does any of this actually matter? Because around the turn of the 20th century, mathematicians discovered that the supposedly perfect, unshakable foundation of their entire field had deep, terrifying cracks in it.
I mean, this was a total shock to the system. For centuries, math was seen as the one source of absolute, objective truth. But this crisis showed that even in pure mathematics, the justification for what we believe to be true depends on our starting assumptions. It involves subjective choices.
What really set this off was a series of paradoxes, and the most famous one is known as Russell's paradox. It's a bit complex, but it basically revealed a fatal flaw in the logic of sets by asking a simple question. Does a set of all sets that do not contain themselves contain itself? Thinking about it just leads you to an impossible contradiction, which proved the logical system itself had a fundamental flaw. This forced mathematicians to confront these deep philosophical questions about what math really is.
So the implications here are they're massive. This whole debate calls into question the fundamental assumptions of all logical systems. It challenges the claim that science can ever be purely objective. And maybe most profoundly, it reveals that human choice, our philosophical starting points, are at the very root of even our most certain knowledge.
And all of this leaves us with one final and honestly pretty unsettling question. If the rules of logic aren't absolute truths that we discover, but are instead conventions we invent or structures we create, then what does that say about certainty itself? If even mathematics rests on a foundation of human choice, what, if anything, can we ever truly know for certain?